I'd like to welcome you all here today for what should be a very interesting discussion. It should have been entitled "Commonwealth Confronts Climate Change," all the C's, which is one more example, I might say, of what has been, I think, a very successful and very enjoyable collaboration that MIT and the Energy Initiative have had with the Commonwealth on everything from research projects to these kinds of discussions in terms of how we look at some of the big issues that we are confronting. I think timing is everything, and the president's inaugural speech on Tuesday certainly put climate change back into the discussion. I might add also that I am fortunate to serve on the President's Council of Advisors on Science and Technology, and in our last meeting earlier in January, we had a good discussion on some climate issues, including the questions of climate preparedness, which is clearly going to be an important part of, I think, today's discussion as well. My role here today is very enjoyable and short. I will introduce the moderator, and first, actually, I'm going to recognize the mayor of our fine city, Henrietta Davis, here in the front row. I think many of you are familiar with Henrietta's long engagement in energy and environmental issues. I'll just say that, among other things, and maybe she'll have a chance to say a few words about this later on, I think recently kind of getting started a climate change vulnerability assessment here in Cambridge, which is, I guess, part of this preparedness agenda. The panel today is going to be moderated by Bobby Kates-Garnick. She's the Undersecretary for Energy in our state government. Specifically, she has a role as co-chair of the Implementation Advisory Committee for the Massachusetts Global Warming Solutions Act 2008. She will describe what are the goals and the programs here, and then introduce all the panelists. I'll just say very briefly that, again, we've had a great pleasure collaborating with Bobby over this last year or so, and very briefly, she has a rather distinguished and interesting set of activities behind her in both the public and private spheres, everything from a public utility commissioner to having been a corporate vice president at Keyspan to working in New York to help get some urban initiatives involving, I think, big data, et cetera, put forward. So she has a broad set of experiences, and I'm going to introduce Bobby Kates-Garnick, and she will introduce the panel. Thank you.
Great. Thank you, Professor Moniz, for that wonderful introduction. Can you hear me? Great. First of all, it is indeed a wonderful opportunity for those of us from the Commonwealth of Massachusetts to utilize our great intellectual resource of MIT to tackle one of the greatest challenges that we of the world are facing. So thank you very, very much, MIT and Professor Moniz. With me today is my co-chair, Undersecretary for the Environment, Phil Griffiths. In addition to our distinguished panel, a person who works very closely on this issue with us is Stephen Clark. He's an assistant secretary. He is returning from the inauguration. But Aisling O'Shea, who was very also involved in our efforts, is here, as are all of the leaders of the Commonwealth's subcommittee team working on climate change issues. So I would ask all of them just to stand up, because these are the people who we work most closely with and who are very active and making, I will say, great intellectual contributions as well on this topic. So we have a very exciting panel. As Professor Moniz said, it was the president this week who really added the push that we need on this issue of climate change. And it is fantastic that he did so in time for our conference, so we should thank him very much for his timely mention of this topic. I don't want to take a lot of time away from our speakers today, so I'm just briefly going to lay out where we are today in the Commonwealth of Massachusetts, and I think that will help frame the issues for our panelists and for you, the audience. In 2008, Governor Patrick signed into law the Massachusetts Global Warming Solution Act, which is a signature piece of legislation that mandated the most ambitious greenhouse gas reduction in the nation at the time. Our agency, the Executive Office of Energy and Environmental Affairs, has the responsibility of implementing this law. And there was a goal set of a reduction of greenhouse gas emissions based on a 1990 baseline of 94.4 million tons of carbon or CO2 equivalent. That is the baseline from which we're working, of which 89.8 million tons of carbon dioxide equivalent comes from energy, and 4.7 is derived from non-energy sources such as industrial processes, agriculture, and waste. So that is the baseline against which we will measure our progress. In promulgating the Clean Energy and Climate Plan for 2020, which was issued in December 2010, we established a 25% goal for 2020 and sought ways to begin the journey to an 80% reduction from that 1990 baseline by 2050. The challenge is huge. In 2011, we also released the Climate Action Adaptation Report, which laid out a set of potential strategies to help us prepare for and respond to impacts of climate change. Again, that's something we'll discuss today. We're also very committed to RGGI, the Regional Greenhouse Gas Initiative, a regional approach to reduce emissions from our electric generation sector, and we take those funds that we get from RGGI and we invest them in energy efficiency and clean technologies. So let me briefly describe our plan. In order to implement this act, we created a Global Warming Solution Act Implementation Committee, which consists of a broad range of stakeholders. And on the government side, we created 5 subcommittees, though in those subcommittees, we seek a lot of input, not only from the members of the Global Warming Solutions Act Implementation Committee, but also from the public at large and anybody else who is really interested in playing a role. Those committees, those subcommittees, which meet regularly and establish metrics and baselines, are the following. 1, buildings, energy efficiency, and demand-side management. And I want to point out to you that the building sector is responsible for more greenhouse gas emissions than any other sector in the state, and it's about 41% of our emissions. Energy generation and distribution, and through this subcommittee, we look at the development of renewable generation through the state RPS program, RGGI. We look at low carbon imports, and we look at coal plant retirement. So all of those type of issues fall under energy generation and distribution. Transportation, smart growth, and land use, that's pretty self-explanatory. Non-energy emissions, and climate change adaptation are subject for today. So in order to move quickly into the panel, I just want you to know from our perspective it's extraordinary because we have an opportunity to look at both the academic side of things and also sort of where we are on the front line of 2 key agencies. One, the Water Resource Authority, which is doing a lot of work planning and working on adaptation and mitigation, and also from the Department of Agricultural Resources, which is getting involved in a whole series of issues as well. And I think it's important that we look at a broad spectrum of industries that are critical to our our state economy. Agriculture actually is much more critical than we even realize, I think, in addition to a major state agency like the Water Resource Authority. So to begin, first of all, we will have our MIT professors speak, and then we will go on to the state. So we have Professor Emanuel, who is a professor of atmospheric science, and Professor Greenstone. I had not met him. Is great. Hi, welcome. And he will give us the environmental economic perspective. We have the mayor of Cambridge here, who does not know it, but if she would like to say a few words at the end, we would be honored to have her. We have Commissioner Watson, as I said, from Agriculture, and we're going to begin with the Director of Planning from the Massachusetts Water Resources Authority, Stephen Estes Margassi, who is also an MIT graduate. So I'm going to turn it first over to Professor Emanuel, and then we'll go from there. Then it's going to be Professor Greenstone, then it's going to be Steve and Greg. So thank you very much. Pardon? I think he suggested that we're going to we'll sit after we're done speaking. But I think
that way we can see the screen.
I can't see. Here.
Okay. Thank you very much. Very nice to be here with you today. Thank you for coming. My role in this panel is to sort of set the stage for giving you a little very quick tutorial about what we know about climate and climate change, with a little twist at the end about what it might mean for Massachusetts. So, the first point I want to make is that the notion that we're able to change climate actually has a long history. There isn't anything particularly new about this idea. The elements of what controls the Earth's climate date back to the middle of the 19th century, when Jean-Baptiste Fourier, whose name you might be familiar with in other contexts, discovered essentially the greenhouse effect, that the atmosphere was fairly opaque to infrared radiation, and that this is responsible for keeping our surface temperature much warmer than it would otherwise be. And the dour-looking Irishman, whose portrait you see in the upper right, John Tyndall, was the first to really quantify this using an apparatus of his own construction that you see a drawing of at the bottom. And what Tyndall discovered about the atmosphere is really quite remarkable, that the entire greenhouse effect is based on a few trace gases in the atmosphere. The major constituents of the atmosphere, molecular oxygen and nitrogen, are almost completely transparent to both solar and infrared radiation. So his essential result is that oxygen and nitrogen really don't do anything in terms of the greenhouse effect. It's all attributable to a handful of trace gases, which together comprise less than 3% of the mass of the atmosphere, the most important of which is water vapor, and then carbon dioxide, nitrous oxide, methane, and a few other gases are responsible for that. So it's an interesting idea that the greenhouse effect really does depend on such a small number of gases. Now, realizing this, the Swedish chemist, Nobel Prize-winning chemist Svan Arrhenius, toward the end of the 19th century, did an estimate of what would happen if we kept burning fossil fuels. Now, of course, the end of the 19th century was closer to the beginning of the Industrial Revolution. We hadn't put very much carbon in the atmosphere by then, but he foresaw that industrial activity would increase the carbon dioxide content of the atmosphere, that being a very important trace gas from the point of view of radiative transfer. And he predicted that doubling CO2 would increase global temperatures by 5 to 6 degrees centigrade, which was remarkably close to modern estimates. This was done at the end of the 19th century. Now, Arrhenius thought it would take us 1,000 years to double CO2 because he couldn't have foreseen the rate at which the Industrial Revolution would take off. And being a Swede, he thought it would be a good thing if the world warmed up a bit. So this is what happened. What you see on this graph is the global mean temperature of the planet as measured instrumentally all over the planet. This is a very well-sampled measurement. There's not much error bar on this. It's surprising in a way. That's what you see in green. And it's plotted in degrees centigrade relative to its long-term mean over the period. And the blue curve is the log of the natural logarithm of the concentration of CO2. The radiative effects of CO2 vary with more or less with their natural log. So that's the quantity you want to see. And you can see there's a pretty tight relationship. Arrhenius made a forecast. Although he got the time scale wrong, he got the basic effect in the magnitude right. And this is the problem that we're dealing with here. Now, I want to talk about principally what this means for weather, but let me preface my remarks with saying that when we're talking about global climate change, nobody really cares whether the temperature goes up a few degrees. On a day like today, it would seem to be a good thing. What we really care about, what matters economically, what matters a lot of things, are side effects of that global warming. One of which is very important, but I won't have time to talk about today, is sea level rise. Sea level rise is projected to be on the order of 1 meter by the end of the century. That's 3 feet. But we know that the planet is capable of rather sensational changes in sea level. For example, 20,000 years ago, which is the blink of an eye geologically, the sea level was about 400 feet lower than today. All that water was locked up in continental ice sheets associated with the last glaciation. There are still ice sheets in Antarctica and Greenland. We don't actually understand their physics nearly as well as we should. But based on that and the thermal expansion of seawater, we expect sea level to go up 1 meter. That is, I think, in the view of lots of us who study this problem, a fairly conservative estimate. It could be somewhat more than that. But aside from sea level rise, what gets us are weather extremes, and that's what I want to talk about a little bit today. So among those extremes are things like heat waves. We in the United States are used to heat waves. We don't generally think of them as killers, but they are, actually. And in Europe, the heat wave of August 2003, and you can see on this map estimates of heat stress owing to that heat wave, with red being extreme, killed about 35,000 people, or led to premature deaths of about 35,000 people. We start to have problems when it gets hot. And if we look at climate model projections of what might happen over the next 100 years or so, this is what you see here. This again is the temperature anomaly with respect to the mean between 1961 and 1990 in degrees centigrade. The black is from observations. The red is from a climate model run with the observed changes of greenhouse gases, volcanoes, and so forth from 1900 to the present, but then continued on to the future with a particular estimate of greenhouse gas emissions. And you can see, of course, that on top of this long-term trend is rather large natural variability. In fact, you can easily find periods on this graph of 20 years long where there isn't much mean change, but there's a net upward trend. And on here you see the heat wave that I just referred to in 2003, and you can see that by the middle of the century that becomes fairly routinely violated, okay? Now, people adapt to heat, but there is an adaptation limit, which I'll talk about in a minute. Here are some other, here's another graph that gives you an appreciation of how the extremes are changing. This is simply looking at all the measurement stations in the United States and looking at the number of all-time record highs set by those stations and the number of all-time record lows. And if you go back to the 1950s, they were about evenly matched, which is what you expect in a stable climate. You're breaking records at about the same rate. But beginning in the 1980s, and particularly in the 90s and 2000s, you start to see a dominance of high temperature records being set over low temperature records. And in the last few years, this ratio has gone up to as high as 9-to-1. All right, so this is another signature of climate change, is when you begin to see an asymmetry in the record breaking. Now, an interesting facet of human biology is that our bodies can only survive up to a certain temperature. And what we're interested here is not the temperature itself, but something called the wet bulb temperature, which is literally the coldest you can make a surface by evaporating water off of it in a given temperature and humidity. And our skins are approximately at the wet bulb temperature, and we can't tolerate wet bulb temperatures that are much above our body temperature. There's just no way for us to get rid of heat. and so we expire. And what you see at the top there is in the red, is basically a probability distribution in red of this wet bulb temperature in the present climate. And the dashed vertical line shows you the human biological limit to that. Fortunately, it's essentially never exceeded in the current climate. The middle graph is an attempt to replicate that with climate models for the current climate. And the bottom graph is for a rather large, large tail end of the projected increases in global temperature, shows that distribution in red, in which case it's rather commonly exceeded. And so if we ever get to that state, we have a real problem unless everybody can get into a cool air-conditioned space. You start to go across this actual threshold where you can't survive. Now, besides temperature, there are hydrological extremes, and this is a complex and fascinating subject. I can only skim over it now. Broadly speaking, the two extremes that constitute perils to us are floods, of which you see an example here, things like blizzards, and drought. Now, a prediction that was made some decades ago about global warming, which sounds paradoxical, but it's very robust. We understand it theoretically. We don't need big, giant models to show it. We can show it in a few lines of math, is that as the planet warms, you actually increase both of these hydrological extremes. Rainfall and snow become concentrated into rarer but much more intense events. So thunderstorms produce more rain, for example, but they don't occur as often. Ditto with big mid-latitude storms. So you actually expect to see an increase in the incidence, ironically, of both floods and droughts, and we're beginning to see that in actual climate records. Severe thunderstorms take an amazing toll. In the United States in the year 2011, they were responsible for most economic damage by weather events. And they have attendant phenomena like tornadoes and hail. You don't hear much about hail, but if you work for an insurance company, that's practically all they talk about some years. Amazing losses from hailstorms. The fact of the matter is that my profession doesn't know at this stage how severe thunderstorms and these attendant phenomena respond to climate change. We haven't a clue. I consider it a cultural failing of my profession because the kinds of folks who study severe thunderstorms are not the kinds of people who study climate and vice versa. They don't talk to each other. This is a big problem. It's also a huge opportunity for graduate students. So if you're interested and you're a graduate student, come and talk to me afterwards. That was my sales pitch for the day. Now, I work on hurricanes, and here there is a little bit more to go on in terms of what we expect. Here's a result that I think this audience is the first to see, which is based upon a downscaling technique we developed at MIT that we had previously applied to the last generation of global climate simulations, but have just applied to the most recent generation. This is simply a projection going forward, also a hindcast, decade by decade from the 1950s to the end of this century of the global frequency of tropical storms. There are currently about 80 per year. This is based on downscaling 5 global climate models, and the boxes and whiskers give you an appreciation of the spread among those 5 models. There's quite a bit of spread, particularly going forward, but there's also a substantial upward trend. For those of you who know something about emission scenarios, this is the 8.5 watts per meter squared, or RCP 8.5 emission scenario, showing an increase. This is rather novel. We didn't see such an increase when we used the same technique on the last generation of climate models. Here's a somewhat more meaningful metric, which is the amount of energy dissipated by tropical cyclones globally. Going forward, that also goes up rather substantially. And so when you translate this into economic damage and conflate that with the sad fact that people are progressively moving into hurricane-prone regions for some interesting reasons, by the way, including right here in Massachusetts, people moving to the Cape and the islands and so forth. This is perhaps bad news. So what we generally see when we look at hurricanes is that global warming certainly increases their intensity. It increases their rainfall rate, and in some cases may also increase their frequency. Now, if we use the same downscaling technique applied to two models, one on the left and one on the right, for regions within 150 kilometers of where you're sitting, this is what we see. So the graph is in the form of a return period. That's the sort of a way of expressing the frequency or inverse probability of events going forward. So this is the probability of experiencing a wind speed that you see on the ordinate there in the quaint unit of nautical miles per hour. Don't ask. The blue is for the current climate, and the red is for a climate about 60 years from now, according to this 8.5 projection. And you see that in both cases, well, first of all, you see that the scales on the axis of the two models, there's one model on the left, one model on the right, are quite different. Please notice that. This is a problem that plagues projections using climate models. This is enormous uncertainty. One model differs a great deal from the next. So in fact, the HADGEM, which is a British model, predicts much more risk in general for Boston than does the GFDL, which is an American model. But you'll notice that going to the warmer climate, both models project a decrease of the return period, which means an increase in the frequency of events in all intensity categories. Now, the insurance industry is one sort of canary in the mine for climate change, and this is all states. This is an interesting non-dimensional number called their net combined ratio. It's basically the ratio of their net payouts to their premiums. And this is the graph going forward. This is just that part of the losses which are attributable to non-hurricane, non-earthquake. So you're looking basically at severe thunderstorms. And they look at this curve and they come to people like me and they say, what's going on? And we don't know what to tell them, okay? This whole industry has suffered an almost catastrophic increase of normalized losses this way. And is this climate change? Well, we don't actually know the answer to this, but there's plenty of interest in industry about whether trends like this are going to continue. So projections of climate change effects on weather extremes vary a great deal depending on the type of event and model projections, but there are some points of commonality that we have to be concerned with. Heat waves become more frequent, but there is a high level of adaptation to heat waves, natural adaptation, up to this limit that we discussed before. It's a very interesting thing that in the United States, mortality from heat waves peaks in early June. Not when you'd expect it to in mid-July, because by mid-July people have adapted on that time scale, okay? But there's a limit to which that can happen. Increase incidence of floods, we expect to see that. We see indications of that already. Increased incidence of drought, ironically, goes along with that. The frequency of intense hurricanes is projected to increase, including here in Boston. But we don't know very much about the response of severe thunderstorms to climate change, and we really need to work on that. Nor do we understand the response of hybrid events like Sandy to climate change. But that, coupled with somewhat more robust predictions of increased sea level, are plenty of cause for concern. Thank you.
Thank you very much. Professor Greenstone, we will now learn about the economics.
Okay, thanks very much for the invitation. It's always a pleasure to see Kerry talk. A little daunting to follow him. I'll try not to mess up my brief foray into the science. So my thesis is going to be why climate policy needs to get serious about adaptation. And I'm going to try and make that point by going through what I'm going to call 8 observations or facts. So we'll start with 1. Kerry covered most of this, but climate change is projected to alter the environment in very dramatic ways. And everyone has their favorite way to display this graphically. This is my favorite way. The yellowish bars are the average number of days that the typical person in the U.S. faces where the temperature is in the ranges indicated at the bottom. So the modal day is, so the average person faces about 70, 75 days a year where the temperature is between 60 and 70. That's the average of the daily high and the daily low. And you can see that for that little sliver in the greater than 90 category, basically people face almost no days where the average temperature is greater than 90. And again, remember that's the average of the high and the low, so it's a really hot day to be over 90. In Arizona they have more, in Minnesota they have few. The key thing is that the red days, the red bars are the change in the number of days that the average person will face by the end of the century under kind of a state-of-the-art climate model and a standard projection about increases in rate of greenhouse gases. And what the astonishing thing is, you see this really dramatic increase in the number of very, very hot days. And one of the points that Kerry was making is that a lot of the damages that we think are associated with climate change are concentrated in the extremes. And so, if you take this model literally, we'd have, maybe 45 more days in the 80 to 90 range and maybe 30 days greater than 90. Right now we have about 1 day greater than 90 for the average person. So just really dramatic changes. This is just in temperature. Okay, the observation 2 is that the projected, so I should emphasize several of these observations by themselves I think are not especially deep or insightful, but maybe together I think they're going to lead, at least they've led me to one conclusion, and maybe they'll lead you to the same conclusion. The second is that the projected costs of climate change are substantial. According to the 4th report of the IPCC, we can have all these different things happen: water stress, people moving across countries, conflict associated with that, changes in farming productivity, increased mortality, morbidity, and a series of things, that many of which we would choose not to have. Now, on the other side, there's probably some positive things. I guess we see a lot of people fighting over who's going to have access to the Arctic. Okay, so what are we going to do? Climate change is going to change the world. It seems on net likely to be adverse. And I think it's important to wrap our minds around what are our actual choices. So the first is mitigation. That's just, we're going to somehow find a way to release fewer greenhouse gases in the atmosphere. The second would be that we could fund basic R&D of low carbon energy sources. That would be great for MIT. We have some excellent ideas on how to spend that money. The third, geoengineering. I think depending on if this is polite company or impolite company, you're allowed to talk about it. And then the fourth is adaptation, which is that climate change is going to happen and we're going to have to find a way to deal with it. And in truth, we'll probably like to end up with some mix of these. My argument, and so let's just talk a little bit about what adaptation is. According to the IPCC, adaptation is adjustment in natural or human systems in response to actual or expected climatic stimuli or their effects which moderate harm or exploit beneficial opportunities. In English, what does that mean? That means the world's going to change and we're going to have to find some ways to protect ourselves from the bad parts and take advantage of the good parts. And the thesis of my talk is that we have to be more serious about that. And part of the reason is I don't think we really have a very large playbook of ways to protect ourselves from the bad parts. And we're probably just developing ways to take advantage of the good parts. And this is going to be especially salient for developing countries. I will come back to that. So the fourth observation is national mitigation policies, so that is policies at the country level to reduce greenhouse gas emissions, by my observation, have not generated a lot of enthusiasm, that's notably outside of the EU, among developed countries or rich countries. And I say that as someone who listened to the inaugural speech and thought this is just fantastic. The president is making a big effort on this. But I think if we have to be realistic, I'm not sure everyone in the country agrees with the president, and the politics have proven to be a little harrowing for having national mitigation policies. And so why might it be that that's the case? And as an economist, I am well equipped to answer that question, and it's always about the money. And so let's just put that in context. What does that mean, it's always about the money? So this is what it costs currently to produce a kilowatt hour of electricity in the United States. An existing coal plant can produce it for about 3.2 cents a kilowatt hour. A new natural gas plant, so this is the great discoveries of shale gas, have really brought down the price of that. It's about 4.1 cents. A new coal plant with modern equipment on it would be about 6.3 cents. And then we get to the zero carbon ones, and not quite zero, but reduced carbon. And so a wind turbine in an optimal place, that's not everywhere, but an optimal place, could produce a kilowatt hour of electricity for about 7.5 cents. And you'll notice it plus a natural gas backup. So this is the problem with wind and solar, is that they are intermittent. And so what I've done is I've created kind of a Frankenstein plant that is able to deal with intermittency. And so that would produce a kilowatt hour of electricity for about 7.5 cents. New nuclear is about 10.5 cents, and new solar would be almost 11 cents. And so just put your mind around that. You know, that's roughly double, maybe 2.5, maybe 3 times as large, to get a zero carbon kilowatt hour of electricity. And that adds up. We spend a lot of kilowatt hours. I should also mention, I don't think, based on current projections, there's probably been more technological progress in reducing the cost of fossil fuels than in reducing the cost of low carbon energy sources in the last several years. And a lot of that is because out of nowhere, we're suddenly awash in fossil fuels. And so here's one of my favorite maps or figures for demonstrating this. And this just shows the reserves of natural gas using from shale. And then below it is the current consumption of natural gas. And by the way, these numbers keep getting, this is from 2009, these numbers keep getting revised upwards and upwards. And at this point, I think basically the United States has figured out how to access the shale gas, but most of the rest of the world hasn't. And if you look at China, there's about 1.5 times as much technically recoverable shale gas as we have in the United States. So I think the point I want to make is that the world is awash in fossil fuels, and probably it's going to remain that way for a long period of time. And I think the temptation, you should think of it as, this is a bunch of $20 bills that's laying underneath the ground. And the history of mankind leaving $20 bills laying around in the ground is not a very long one. Okay, observation 5. Climate change cannot be contained without cooperation from developing countries. So if we could really get it together and we had our own policy, we would still need the rest of the world to come along. And here's just one way to illustrate this. This is atmospheric concentrations of CO2. I think we're probably close to 400 now, depending on how you calculate it. And the 2 lines show you what would happen if the United States by itself achieved something like the president had originally proposed in 2009. And that's the lower one. And then if the whole world did nothing, that's the higher one. And the point is not that, this is not an argument that the U.S. should not be doing this. The U.S. could be a leader and motivate other countries to participate. But I think it just highlights the math of we're going to need reductions in greenhouse gas emissions from the whole world. This can be seen in a lot of different ways. One is just the forecasted change in energy consumption from the OECD or today's wealthy countries versus the non-OECD, which would be the red line in this graph. Okay. I think in putting it into context of what we would actually be asking developing countries to do, this is one way to do that. So the black line there, the full line, is China's baseline emissions scenario. So this is what's projected to happen if they have no real carbon policy to the end of the century. And this would be their annual emissions of CO2 equivalent. The red dotted line would be their emissions if the world were on a path to 550 parts per million, which is higher than I think many people are comfortable with, but might be the most realistic goal we have out there. And the space in between is basically the reduction China would be responsible for every single year. And as you can see, that's a pretty wide space. So what I did was I went and got some estimates of GDP for China under the black line, and then some estimates for GDP under the red line. And you might ask yourself, well, what would we actually be asking China to do if we were to ask them to be on the red line, or the set of red dots. And the present value of the reduction in GDP, so that is you take the loss in GDP we'd be asking them to incur every single year, and then say, what's the value of that in today dollars? It's $51 trillion. So that's like 3 years of US GDP. I don't remember the Chinese GDP off my head. Let's call that maybe like 6, 7, 8, 10 years of Chinese GDP, of today's Chinese GDP. So the point is, this is going to require massive effort, not just from the United States, but from countries who are facing the real problem of not being nearly as wealthy as us. And that leads to the next observation. Developing countries are likely to be even less enthusiastic than developed countries about reducing emissions. And there's a lot of different ways that one could illustrate that. Here is a numerical way. You could just point to income. The United States per capita income is almost $50,000. It's in the mid-30s for the EU and the UK. Developing countries, they're off by an order of magnitude relative to the United States practically. In India, it's about $3,000. In China, it's about $6,500. And the reason that's important is the low incomes there mean that in econ speak, we would call that they have a high marginal utility of income. So what does that mean? That means they would love to trade income tomorrow when they're going to be wealthy for income today. And of course, the problem with reducing carbon emissions is you're actually asking people to do the reverse. You're asking them to give up income today in the name of some benefit in the future. And it's a very challenging, it's a challenging request. It also does not seem to be paired with a request from rich countries to compensate developing countries for this loss. Okay. I think it's also worth highlighting that developing countries are relatively unprepared to confront climate change. And we're going to talk later about some of the important steps the state of Massachusetts is taking to prepare for climate change. I think it's worth taking a temperature, so to speak, of what the state is in developing countries. And so here's from some of my research. And there's a lot of motion on this graph, so let's just try and explain it in words. What this is, and actually, you know what, and this is Celsius, so let's just go to Fahrenheit. The blue line is the relationship, the mental exercise that you should think about is, if I take a day from the 70 to 75 range and shift it to one of these other ranges, so this is in Fahrenheit, 80 to 85, 85 to 90, et cetera, what will happen to mortality? And the kind of astonishing thing, despite Kerry's focus on heat waves, is nothing happens. In the United States, as you move days around, which climate change will do because we're going to have many, many more hot days, it has, to a first approximation, no impact on mortality. And why is that? That's because we're wealthy, we're well adapted, there's all kinds of air conditioning brewing in this room, and on cold days there's heat going on in this room. So that's the United States. The full red line, and you'll just have to excuse the statistical noise that's jumping around there and focus on the last few dots to the right, is from India. And this is using death records from India from 1957 to the present. And it's conducting the same exercise. Let's take a day that's between 70 and 75 in India, and then due to climate change, why don't we bump it up to 90 or 95? And the astonishing thing is that one extra day in India that moves from this kind of moderate temperature to a high temperature would increase the mortality rate, annual mortality rate, by about 1%. And a different way to say that in English is they're not well prepared for climate change. And so if you're India, and I want to just come back to the previous point, if you're India, what would you really like? You want that blue line. You do not want the red line. The red line is filled with misery. It's filled with people dying. It's filled with hardship. It's filled with sickness. And what's the best way to get to the blue line, unfortunately? I think the best way to get to the blue line is probably to get richer. And so that is part of the dilemma of it confronting climate change, is that we're effectively asking countries who are relatively poor to incur lots and lots of costs. Okay, so all of that, I think, points to, gosh, what do we really need to do, or what can MIT researchers do, in addition to contributing to the science of climate change, well, we could try to find successful adaptation strategies that other countries or the United States or Massachusetts may use. And to do that, I'm just going to give you a brief little interlude of one example from some of my own research, which just looks at how the effect of hot days, so this is the effect of hot days on annual mortality rates over 2 20-year periods. And you can see that there's just been a remarkable decline in the impact of hot days on mortality. And so in the beginning of the century, a hot day increase, a day greater than 90, increased the annual mortality rate by more than 2%. By the end of the current period, it's down to basically 0. And what we tried to do, my co-authors and I in this paper, was try to figure out, well, among several innovations that we could measure, and the ones that we measured were the proliferation of doctors, the proliferation of residential electricity, and then the proliferation of air conditioning, which of these could help explain this? And this is too many numbers on one slide, so let me just say in English, what that table says is that virtually 85% of the entire decline is due to the proliferation of air conditioning. So at least so mortality is only one part of what climate change will do, but at least with respect to mortality related to hot days, this research would suggest that the proliferation of air conditioning. Now, unfortunately, it has the feature that would produce more energy consumption, and as we talked about, maybe energy consumption based on fossil fuels, but maybe this could go into the playbook of adaptation strategies. So let me just conclude. Climate change is projected to lead to dramatic changes in the environment. Global mitigation is going to be very challenging, in my opinion, politically and economically. And then maybe to overstate the case, adaptation is the one climate policy that we're absolutely guaranteed to pursue. However, the playbook of successful adaptation strategies, I think, is rather small. My own view would be that adaptation and R&D should move higher on the policy agenda. Thank you.
Thank you very much. I think the challenges for us are very immense and made clear, and I think we're going to now go to the Water Resources Authority, to the Director of Planning, Stephen Estes-Margassi, and he will give us a brief overview of some of the critical issues that the MWRA is facing and how they are beginning to address some of them. So thank you.
Okay. Thank you. Daunting to follow all of that science. I'm not going to spend a lot of time on the slides. You've got the words. I'm going to pick 1 or 2 points on each slide for you to pick up, and you can always ask questions. All right, what button am I pushing on this? All right. Okay, so as I think as our Director of Planning about what we need to think about, we're really focusing on 2 separate areas and maybe equally weighting them in our thought process. Adaptation, understanding the impacts, figuring out how to mitigate them, create resiliency in our system. We want to be resilient not just to climate change, but a wide variety of other things. And then mitigation has a bunch of attributes. They're good, reduce greenhouse gases, we could get to contribute to the common good. Not only that, we also get to reduce our costs. It's a high priority for us, and maybe improve our public perception. When you think about my job as Director of Planning, I like to try and shorten it up. What do we have to do? My job is to make sure that our customers can drink water with confidence, that they can flush with pride. We don't have an environmental footprint that's too bad. You notice accomplished affordably, driven home by many meetings with the public. And the real challenge for us is under all circumstances. Folks expect to be able to turn on the tap and have clean, safe water come out, flush the toilet, and their waste go away without creating problems for others all the time, under all circumstances. During a hurricane, during a drought, we still need to provide that service. We've been thinking about this for a while, and I guess I get to say we have the first significant concrete effort at adaptation nationwide, perhaps worldwide. When we were designing the Deer Island plant back in the 1980s, this is where your sewage goes when you flush the toilet. our engineers realized that if sea level rose, that the capacity, the hydraulic capacity of the outfall pipe would be reduced proportional to as sea level rises. We raised the entire plant based on that 1989 design almost 2 feet to ensure that for some period of time, depends on which set of projections you look at, we would have the stated capacity of the plant available. So kind of interesting, kind of fun. We've been at this, as I said, for a number of years. Not only our external designers, but our own internal staff. We've been thinking about this for a couple decades. And the fun thing I like to show this slide is 2 things. We have lots more models to play with results, and the grid cells get to be much more interesting. When I first started looking at reservoir impacts back 20-some years ago, we had one cell that covered pretty much all of New England. That meant that where my customers lived and where the rainfall fell, all in the same cell, all treated one way. We now have much more discrete cells and in fact can downscale that to individual rain gauges. Makes it a little bit easier to do your work. Preliminary conclusion, based on 20 years and multiple iterations of looking at it, with our very large reservoirs, our water supply is well situated to adapt to climate change. In fact, we might be better off. The MWRA may have some water available to sell to folks who don't have water available. So here in Cambridge, when that drought does come, you can open up those valves and buy water from the MWRA as you have over the years in other crises. That's something that may become more frequent. So despite increased variability, big storage means we'll be able to capture it and use it. Sea level rise may be a different story. You can see my office there. I'm a bit concerned. So we want to look at our coastal facilities and think about this. And many of you have probably seen maps like this, and they're kind of cool. You look at a map, you show the flooding. It's nice to see that a particular dot on the map says a facility is in an area that might be flooded. That's interesting, but not enormously helpful. So what we've been working on over the last few years, based on some work that we stole from folks out on the West Coast in King County, Seattle area, is to look at individual facilities under a variety of sea level rise conditions and a variety of storm conditions, a 5-year, a 10-year, a 100-year or more recurrence interval storm or low probability storms, and see what it means for building. And in fact, this morning, I spent time with our engineers who are in the process of renovating this building, trying to figure out what can we do to make this building somewhat more safe, able to function, or able to be recovered after a major storm as we're renovating it. So we have looked at that, and basically what it says is prepare for inundation. How much inundation, I think, will be the $64,000 question. There is definitely a cost-benefit analysis to be done as we think about it, but we need to make sure our shorelines are well armored. We need to move electrical equipment up out of danger. New York City has been doing this. We're working on this. If you've got an electrical panel, move it a little higher in a building. Maybe you put in a storm barrier in front of a big garage door that enables that building to not flood under another 18 or 24 inches of rainfall where it might have otherwise. Relatively simple things in some cases. However, as the levels go up, and we did look at some more substantial categories of hurricanes this morning, and at a certain point you say, well, it'll be wet. What do we do to recover? And so that's the other thing we're looking at is how do you shut down a facility, evacuate, if you will, mothball it for the short term so that 2 days later you can turn it back on. There is a substantial difference in economic impact and societal impact if you have a wastewater facility that is not operable in the midst of a major storm for a day or two. A big difference if it's been 6 or 8 or 12 weeks. And we don't want to be there. And you see some of those good examples from Sandy in New York where some things were able to recover within days or weeks, and other facilities are still not fully up to snuff. So as we think about adaptation, this is my last slide on adaptation, think about how do you do this? Do you have a climate change capital budget? And I would argue, and have argued, that that's not a good strategy. What we are doing is we are maintaining and upgrading our facilities as part of a long-term program, and anything that's got a motor in it, anything that's got an electrical component, we'll be touching every 20 years. So during that normal renewal cycle, we're going to make sure that we're taking care of that facility. Now that's not to say that if there is an inexpensive way to make something safe for the next big storm, which could happen next week, that we're not going to do it. But we're not going to necessarily go in and make a major renovation of a facility just for climate change. When we renovate it, we're going to make sure that climate change is incorporated. And this is, I think, a way to make sure that your plans are well equally dealing with a wide variety of things. We worry about earthquakes, we worry about floods, we worry about droughts, we're worrying about climate change. In our capital budget, it's built into our thinking about individual projects. Adaptation's great, we're all going to have to do it, but it's good as a citizen to think about what you can do to better the planet. So we are also thinking about energy efficiency. Our governor has suggested we work on it, and we are working on it as part of our implementation of Executive Order 484, but it's also good because it saves money, it helps us as we're replacing equipment, and it does help us with our public feeling that we're doing a good job. Why do we care about it? Well, water and wastewater is pretty energy intensive. Our demand, the numbers are up there, is the equivalent of a small city, roughly the size of Arlington in terms of the amount of energy we use every day or over the course of a year. Our costs are high. Roughly 10% of our budget is spent on energy. Big deal for us, one of the few things that we have the ability to dial down or up. We're not going to deal with the capital costs, those are sunk. There's things we can't change, we may be able to deal with energy. When we look at our current portfolio, just about a little under half of our use of energy is from renewables. This is way up from where it was 15 years ago, something we're working on quite heavily. And we have a pretty wide range of assets that we're looking at for this, and I'll pick off a couple quick stories to tell you about. At Deer Island, our giant wastewater treatment plant, one of the largest in the country, almost a quarter of our electricity is generated on island through renewable sources. And when you look at our total energy profile, that includes fuels we need to use for heating, as well as the things we use to turn motors. About a little over half of our energy on that facility is generated from renewable sources. Principal among that is methane. And those of you who know about greenhouse gases know carbon dioxide is bad. Methane is much worse. So not using methane is both a greenhouse gas disaster and a missed opportunity. Methane's a great fuel. So we capture and use 98% of the methane we generate. In fact, we're working hard to generate more methane to be able to make those economics work even better. Just a quick number to capture out of that. Just in terms of heating on that plant, we save 5 million gallons of fuel oil per year by using methane rather than what we might use for other sources. It's a pretty big deal. Hydroelectric power is something we've been at for a longer period. A couple of these facilities date back to the 1890s. We've been doing this for a long time. Our water comes from the highlands out in central Mass and flows downhill. We try and squeeze pretty much all the energy we can out of it as it comes eastward. Interesting factoids here. On hydroelectricity, we generate just about as much hydroelectric energy as it takes to run our ozone water treatment plant out of Marlborough that we supply Metro Boston. So we're basically carbon neutral, if you will, on treatment. When I look at the entire energy profile of the water system, that involves not just the cost of treatment, but the cost of pumping, the cost of vehicles and heating our buildings and so on. Fair share of all the stuff that we run, we're down to about half of our energy footprint is generated by renewables. Now that gives me a chance to pick up one of these, excuse me. And last factoid for those of you who drink bottled water. Our carbon footprint is about 1/10,000th of the carbon footprint of, and this is actually very expensive bottled water here because this is made from tap water, so it's doubly bad. But we're about 1/10,000th of that, which means that if you've got 1/2 liter bottle of Poland Springs, to name a brand, sitting on your desk, that's equivalent to about 2,100 gallons of what comes out of the tap. So think about that next time you're at the convenience store. We generate almost $500,000 a year in revenue out of wind power, thanks to the Commonwealth for a number of quite nice grants to get a few of these things underway. We do care about cost effectiveness, and that does help out, but these are great. When the wind is blowing, we make great power. We've got when the sun is shining, we're making almost $250,000 a year in green power to offset our costs. And when you look at our total energy profile, and this gets back to this, what are we doing to hit those goals of 20% or 25% and then 80% reduction? Our portfolio, when you look at both produced and purchased power has gotten up to about 40% renewables in our energy use profile. We don't just look at the big assets, we look at all the little assets, and you need to do this as you're thinking about running one of these programs. What kind of light bulbs do you have? How are they controlled? Do they turn off when you're not in the room? What kind of vehicles do you have? What are you doing for recycling? Look through that whole program. And I like to say that this was produced on an energy efficient computer. I don't like, it's great to talk about the greenhouse gas stuff, and I know our ratepayers, some of them really care about this, and we do talk about it, but our ratepayers really do care about how much it costs to run a proper, environmentally appropriate, safe drinking water and sewage treatment system. So we do point out how much these type of initiatives have saved, and this is a case where it's win-win. We've got additional capacity to save communities that need more water, we're reducing our costs, and we're reducing greenhouse gases. And I just have to point this out. We've gotten recognized a bunch of places, and the mayor leaned over and whispered this to me earlier, so I do get stuff on the slide here. Yesterday, we were awarded from what's called the ACEEE, American Council on Energy Efficient Economy, in the Alliance for Water Efficiency, awarded us one of 5 nationwide awards, gold medals, I don't know what you want to call it. We haven't gotten a plaque yet, so I don't know what it looks like, for energy and water efficiency programs. So you do this stuff, your ratepayers can be proud of you. So we're pleased with that. I guess that's it.
Thank you very much. Your ratepayers are proud of you for that award, because our Department of Energy Resources also has us #1 energy efficiency in the country from the same organization. So now we're going to talk about agriculture, and then hear from the mayor very briefly, and then go on to get audience engagement.
Good afternoon. It's a pleasure to be here. I'm here to talk about Massachusetts agriculture and how we're responding to and adapting to climate change, and believe it, we already are. This is the shot here is a picture actually of inside of a greenhouse at the Dudley Street Neighborhood Initiative. It's an urban greenhouse, 10,000 square feet. I actually thought about naming this the greenhouse in the greenhouse, because greenhouses are going to probably play a very important role, ironically, in our efforts to adapt to climate change with regard to food. I just want to point out that we in the state government here actually have been looking at climate change for quite a while. A number of years ago, I worked at the Massachusetts Office of Science and Technology, which was in the Executive Office of Economic Affairs. And this was back in 1989. And we kind of did this on the slide. We created a publication called Sustainability. And a bunch of us actually got together. This is when the state actually had an Office of State Planning. We actually talked to one another. We got together and we did things mostly during lunchtime. And one of the things we really did do there was talk about climate change, even as early as that, as having an economic impact and how important it was. And here we come full circle. I won't go into this. Bobby's already pointed out, but talking about the Massachusetts Global Warming Solutions Act, which is, again, sort of a major and profound statement by state government in terms of acknowledging the importance of addressing climate change. But I'm here to talk about agriculture. And agriculture, industrial agriculture, it has had a tremendously negative impact on climate. And in fact, as you see here, the global food system is responsible for nearly 1/3 of all greenhouse gas emissions. 1/3 of all greenhouse gas emissions can be attributable to the global food system. A lot of that, I'm right now focusing on the industrial agricultural system. So this is just a reiteration of that, U.S. nitrous oxides. Quote here, you may not read this all, and by way of full disclosure, let me point out that it's my second tenure as Commissioner of Agriculture. I served in 1990 to 93, and right before my first time serving, I worked at a place called the New Alchemy Institute on Cape Cod. It was one of those ironic deals. Only in Massachusetts could a black kid from Cleveland, Ohio, working at the New Alchemy Institute be appointed Commissioner of Agriculture. And never having worked on a farm, but the feeling was that in order to you are a part of agriculture as long as you eat. And Mel King, a legislator from the South End, was one of the major advocates of agriculture. And as early as 1978, pick up a copy of the the old Real paper, which is no longer exists, but an article on the politics of food in Massachusetts cited Mel King as being the major advocate in the state legislature for agricultural development. And that was a black legislator from the South End. He understood right then that agriculture impacts us all. Now, back to this quote. I've asked people who they might attribute this to. Some people told me they thought it might be Rachel Carson, Wendell Berry, George Mulcraig. You can't chime in here because you probably know. But it's very interesting. And that quote came from Henry A. Wallace. And he was the Secretary of Agriculture. And his 1938 yearbook of agriculture was called Soils and Men. And I will tell you, it probably could right now be the Bible for sustainable agriculture in this country. And this was written in 1938. It was about 800 pages. This was the yearbook of the U.S. Department of Agriculture. And it's talking about soils. He's talking about sustainability. And the reason I bring this up is this is not the whole notion. We talk about sustainability now. We talk about organic agriculture. We talk about relationships of us, of soil. Take a look at that once again. You know, again, our relationship. The earth is the mother to us all. If we had a Secretary of Agriculture who said that today, they probably would get him out of office. You know, you're crazy. You don't have to be in Birkenstocks, and you don't have to sort of, you know, again, sort of be way out. And I say this because I worked at the New Alchemy Institute, so I wore Birkenstocks and I did short. But this is a real statement about where somebody back then said, this is what agriculture is about. And that was in 1938. But in 1976, we had Earl Butz as the Secretary of Agriculture, and his mantra was, we have to farm and plant commodity crops like corn from fence row to fence row. And he said, you know, what he lamented about agriculture back then was that it took 45% of us to farm and raise food for the population of the United States. He says, and since we become industrialized, now 4% of the people only have to work the land. But there had to be a substitute for those human resources working that land, and we know what that was. It was fossil fuels. And again, we industrialized agriculture. It was not inevitable. It was not inevitable. And so when we talk about where agriculture is today, certainly in the United States, and I just wanted to point out that this is not something that has to be. This is not the way that we have to be able, that we need to practice agriculture. And it certainly is not the way that we practice agriculture here in Massachusetts. Missing from this dialogue in terms of climate change and the impacts has been agriculture. And this is just an article that points out that, again, a number of nations around the world have recognized that when we looking at the impacts and looking how we're going to address this important issue, ag needs to be at the table, no pun intended. We can tip the scales and we can turn this around, and actually we're doing a lot of this in Massachusetts. Now, I'm not suggesting, we're a small state, and we actually only provide really about 15% of our own food needs right now in Massachusetts. So I'm not saying that what we do here is going to change the world in terms of what we do on site, but what way we're doing it. This is probably one of the technologies, one of the approaches that I would be very proud if we would export elsewhere, because this is something that is replicable and probably is something, I'm going to say to you right now, is the direction that agriculture in this country is headed in. The large commodity-based agriculture, soybeans, corn, and the price supports in the Farm Bill are really going to be a thing of the past. We work with a number of agencies, Department of Environmental Protection, Department of Public Health, and Northeast Organic Farmers Association to facilitate what we're really calling a sustainable agricultural economy here in Massachusetts. We're composting. We're talking about nutrient-dense soils through, introducing trace minerals, inorganic trace minerals to soil, as well as organic materials, so that we actually improve the quality of soils, and subsequently the quality of produce. A number of our farmers feel that's the niche for us, that we really are going to make a big case in terms of nutritional quality and actually taste as well. They do taste a lot better. Biochar, some of you may have heard of this. It's interesting. The first time I heard about biochar was after reading a book called 1491, The Americas Before Columbus, and about the Amazonian and this creation of terra preta, which is actually a form of charcoal, which is added to the soil and increases its retention of moisture, but adds to the soil fertility. These are things that are actually, it may sound a little strange, but they are things that are making a difference in Massachusetts, and I would say not just Massachusetts, but certainly in Massachusetts around the country. We have a governor who is passionate about agriculture. and we're very fortunate in that regard. So he's put a lot of emphasis on us really sort of developing our Grow Local campaigns and trying to enhance the amount of the accessibility. The buy local, locavore movement, I say to you, is not a fad. I think people have made a very important connection between locally grown food, freshness, nutrition, and addressing issues like obesity, and I'm here to say, and also climate change, as strange as that may seem. Another reason this is important, as the Farm Credit East points out, agriculture in the Northeast really has a significant economic impact. There are a number of reasons why we want to preserve our agricultural base, agricultural resources in Massachusetts. One is certainly for open space, and that's probably one of the reasons why we're located in the Office of Environmental Affairs. Massachusetts and other large sort of agricultural states understand agriculture is either a secretariat on its own, but might also be found under economic development, but certainly not in environmental affairs, primarily because the attitude for a long time was that what we did was preserve open space. And we do that, but we also create jobs and businesses. I won't go into detail here. This is who we are, the Mass Department of Agricultural Resources. When I became commissioner the second time, someone asked where I worked, and I told them, they said, there is a Department of Agriculture in Massachusetts? I said, there is, and we do have a considerable amount of agriculture as well. We preserve our most important resource. When we talk about our potential for meeting our food needs, you always begin with the resource base. I love the fact that the governor has come out very strongly and made very bold statements in terms of renewable energy targets, 2,000 megawatts of renewable energy over a period of time. We need to set some similar goals in terms of what we can produce, how much of our own food needs we could meet here in I'm going to say in the region. And so Massachusetts, again, we're 10 or 15%, but there have been studies, and a number of us get together. One of the groups that we work with is Harvest New England, my colleagues in New Hampshire, Vermont, Maine, Connecticut, and we're looking at the possibility that we could actually meet about 50 to 60% of our food needs in New England. Now, that doesn't include things like grains, obviously, and we can do the tropical fruits and not coffee, so we'd have to import something. Some things are going to be imported, but we could meet 50 to 60% of our food. Now, that means, when I'm saying could we do that? Yes. What are the challenges? Well, probably challenges would include somewhere around 5 million acres of additional land that would have to be dedicated to agriculture. But when we talk about sustainable agriculture, not industrial agriculture, that's not necessarily a bad thing. So we preserve the land, but we also introduce and talk about diversity. We're not monoculture like they are, again, we talk about large industrialized farms. And when we talk about adaptation, we talk about preparing for climate change, just like any other sort of, if you want to preserve and talk about conservation, diversity. Don't put all your eggs, once again, pun intended, don't all your eggs in one basket. You really want to have a diverse portfolio. And people are pretty amazed at the diversity of crops that we grow in Massachusetts. But we're also impacted by climate change, or is it climate change? I don't know. I'm asking the question: is it climate or is it weather? But we've seen again that the maple production is down, and as a matter of fact, you see here it says the 2012 maple season was too warm. Some folks even said, is it even worth tapping? And it's unpredictable, right? The apple crop came in very early. Now, you may say, so what? That's not a bad thing. Well, for a farmer, though, that can have tremendous consequences when it comes to labor. If all of a sudden you've got the crops coming in a lot earlier than you expected, and you have, again, you're bringing in folks to pick those apples, and you start to get these these weird sort of moderations, it does impact. When you're on the ground and you're talking about how this is impacting people today, it could be, in fact, significant. So we're seeing things that happen already. One of the books that I read a long time ago, and you talk about what, I think one of the previous speakers talked about the canary in the climate coal mine. There's a great book, and it's called Times of Feast and Times of Famine. And you talk about how do we look at climate change and how do we monitor it and how do we observe it in the past? It was through food. It was like, what was the grape harvest? A lot of wine. People really did because they like wine and they paid close attention to wine production. But if you wanted to know over time, because there were records, very, very detailed records kept. And I think the guy's name was Emanuel Leroy de Roderay or something. I gave you the name. But it's called Times of Feast, Times of Famine. Really important in terms of the importance of agriculture as an indicator of climate change, but also that it's impacted by climate change. So we're taking a look at that. The Massachusetts Department of Agricultural Resources, we have a role to play. We work with the Department of Public Health, and we have a responsibility when it comes to protecting the public's health and particularly with regard to this past summer, we had the West Nile and equine encephalitis issues across the state of Massachusetts. Characteristically, those issues were really confined pretty much to the southeastern part of the state ever since I can remember. That's really where the high incidence of either West Nile or Tripoli occurred. But this past year, first time that every county in Massachusetts had at least a case of West Nile or Tripoli. We've never had that before, and so now it's sort of like it's a statewide issue. And that, once again, what do? When I talk about the responsibilities, the Department of Public Health determines whether or not there's a safe or a public health hazard. What do? We have to then coordinate to order the anvil, the pesticides, the planes that are going to come in and do because this is for aerial spraying, and how much we order and when that happens. And in the past, it's been confined to a very small area. Now we have to really think, are we going to have to come up with a plan that's going to cover the entire state? And then just in terms of resources, in terms of dollars, it's significant. So the impacts are already being felt, again, sort of across the state. Hardiness zones, we're kind of, again, seeing, again, there's a shift. Nature is making, there's some shifts and things are starting to change in terms of where we see certain plants are being able to grow and where they are not, and where certain pests. We have a new pest here that we haven't had in Massachusetts before. It affects soft fruit, which it gets into the fruit, and it's like you don't see it on the surface. It's one of those really gross things because you open it up and then this thing, you get the maggots and stuff. They all coming out, and you kind of like gag or something. Now this could be the double whammy. The double whammy because we think these may have been blown in by Hurricane Irene. Now, does that mean that, more intensive storms blowing in, again, more invasive species? But the question is, will it survive here? Sometimes you get, invasive species, they come from the south, and then boom, we don't have to worry about it because they can't adapt. But we're finding that some of these are starting to persist. I went to an oversight committee meeting of the Massachusetts the Cape Cod Cranberry Growers Association, and they went over their research agenda for this coming year. And when I looked, it was almost entirely dominated by looking at invasive species, pests. And I said, are you getting any of your research dollars coming in for climate change? And what they said was, the majority of it is, we don't call it that. But that's what we're researching. And they said, what we're trying to do is stay ahead of this and see if we can deal with these new invasive species, but can we do it biologically? Can we do it in a safe way and not having to resort to chemicals because they're getting ahead of us and we haven't had to deal with them before. So these are real things that are actually happening. We're responding on the farm, at least in Massachusetts, in a number of different ways. We're certainly doing by trying to reduce our energy input on our farms with wind, with methane, anaerobic digesters. And by the way, the anaerobic digesters address a number of problems, going back to that first slide when talking about soils. And they're, especially soils that rely upon a lot of chemical fertilizers being the source of greenhouse gases. Well, here you get the cow manure, which you then can mix with your food waste. In this anaerobic digester, you get renewable energy, and then you get fertilizer to put back on the field. So we are really talking about some things that are working on behalf of farmers in ways that are making them much more sustainable, but also much more climate responsible. Solar panels, sometimes a little bit of conflict. Water resources as well. Cranberries use a lot of water. They've been working with us, the Mass Clean Energy Center, and our folks at MDAR. Now with new technologies, some water sensors that are implanted in soil, and yes, cranberry growers all have apps now, and these apps connected with these water sensors, when they sense the moisture of the soil. In the past, particularly in early spring, farmers use water for two things, for irrigation, but also to protect against frost, right? So if there's going to be a freeze early on, you want to protect your plants, so you have to get out there and water them so that you get the ice forming to protect the plant. When that happens in the past, just about 2 or 3 years ago, when they got a signal that the temperature was going to drop below freezing, the cranberry growers basically turn on their pumps and let them run all night. That's the only way that they could really protect. Now, with these sensors and their apps, the water only comes on when it's needed, and in many cases, they are using 80% less water. 80% less water. Now that's energy, that's resources. Those are big savings, and once again, becoming more responsible in light of climate change. I won't go through all this because these are up here too, but these are a number of things that are going on our farms that are indicating that we are becoming a lot more responsible with regard to energy. Quickly, you look at climate change, impacts on Massachusetts. we import most of our food. Where does that food come from, and how is that being impacted by climate change? Drought was incredible over the, as you know, the past couple of years. We import a lot from California. Folks, I don't care what anybody says, nature had a plan for what we call the breadbasket of America, the breadbasket of the world, and that is a desert. And right now, the Colorado River dries up before it can even drain into the Gulf because of all the demands on industrial agriculture for that water. It's amazing how much water. California is now the largest dairy-producing state in the country, produces rice, produces things that, given what its natural weather and climate, should not be, I'm telling you, they should not be doing that. But they are. And so when we say, you look at what's going on in other parts of the country, how might that impact our food supply? And our adaptation response to that is, we've got to start growing a lot more of our own. We are growing more, but we got to, and some of that means conventional agriculture, as I pointed out, with our ag land preservation, diversifying our crops, what we call specialty crops, like strawberries, cranberries, apples, and all. But we're also finding people are becoming very innovative with hydroponics. We're doing a lot of aquaculture. We're trying to do a lot. Back when I worked at New Alchemy, we actually had systems that raise tilapia, catfish, and tanks and use the water runoff to support hydroponically grown tomatoes, cucumbers, and lettuce. The cucumbers, lettuce plants filtered the water, and we put it right back into the tanks. It was an incredibly great closed system. But now, guess what? There's something called the Good Agricultural Practices Harmonized regulations that say you can't have those two systems in direct contact anymore because of food safety issues. So those are sort of things we deal with a number of things in our department. And that make a lot of sense. The other piece, new venues for food production. That's a freight farm up in the upper left-hand corner. Those, again, sort of the freight containers that you see on ships. Well, people are equipping them with LED lights, putting shelves in, and plopping them down. This happens to be in Newmarket Square, but they can almost be anywhere, and they're growing fresh lettuce year-round. Rooftop gardens, rooftop greenhouses, urban agriculture. The city of Boston has now just completed the draft of Article 89, which will allow for commercial farming within the city of Boston. Somerville is undertaking similar actions, and all we're saying is we're going to have to sort of increase those menus dramatically, and that is a little bit of how we're really adapting, preparing for climate change Massachusetts. Thank you.
And now I wish all the panelists would come up, and if Mayor Davis could give us a few brief remarks, that would be great. And then we will start our discussion. I think we're going to go till 5 o'clock, at least that's when we're scheduled to end. So we just have to be cognizant of the time to take advantage of some of what we've heard this afternoon. So thank you.
Thank you very much for giving me the opportunity really to be the first questioner. That's kind of the way I view this spot on the agenda. As you probably all know, Cambridge is a very small city, but we have a very big profile. We think very highly of ourselves, and 100,000 people, but a place where these kinds of conversations happen, and where instead of talking about what shall we do, MIT organizes a fabulous panel like this, and I just want to give them great thanks to us as people from Cambridge for bringing together the wonderful people from the state to give all of us the benefit of their knowledge. So please join me in thanking them for what they've done today. And you know how many times I said brief? Well, I'll try to be as brief as that. So what did Cambridge do? So since the year about 2099, we've been talking about mitigation. We've been very hopeful. We think if we could mitigate our way out of this. But I think what you've all seen recently is that adaptation is something we're not going to be able to avoid. It really was a dirty word in the environmental community in the early 2000s. Never say mitigation. Never say adaptation, they said. Don't even talk about it. But now we realize with the hurricanes and the droughts and all that we need to adapt, and Cambridge is pulling together a large panel of many stakeholders to plan for our own adaptation needs. Why? I think you're going to be underwater in about 10 years. That's why. Because we're here on the edge of the river with a dam that's a cute little dam from the end of the, I think, the beginning of the 19th century, I think, that's saving us from being inundated. So we have to adapt. How can you all help us here today? I think clarifying the message, understanding the economics of what happens if you don't adapt is really, really important for our panel to bring along the building owners and the developers and so on to understand that they cannot bypass these new standards for building. Very, very important, really, to understand what it means if you don't do that economically. You can help us do that. Building science is also terribly important. What really works? I mean, I think we all know, if you ever went to the Florida Keys after the hurricane, you know they put their washing machine and dryer in the basement, and then after the hurricanes, they're all out on the street. But that's only $600, not a big deal. When you're talking about these giant buildings that we're building and running and operating, you can't just put them out on the street at the end of the hurricane. So we need help in understanding how building science can work better. Because you know what? Our residents don't want all the mechanicals on top of the buildings making noise. So we're going to have to figure out some of those things. And of course, the politics. What in the world are we going to do about the politics? Thank you, President Obama. Thank you to Mayor Bloomberg. But this country is not at all on the same page. I'm active at the National League of Cities, and there are still some very dirty words like climate change. You can't even say that. So help us, panel, in bringing the message forward and understanding the technological solutions. And that's my question, ergo statement for you all. And thank you all very much. And thank you to the state of Massachusetts, the Commonwealth, for being such a wonderful leader.
Good. Thank you very much, Mayor. I'm going to turn it over now to the audience for questions, comments, any thoughts that or ideas that were raised today. Yes.
A question for Michael Greenstone. I was cringing a little bit when you kept. Sorry. My question's for Michael Greenstone. I was cringing when you kept saying that we are effectively asking the developing world to reduce their future GDP. I wonder if you could say a little bit more about that. I understand the differential in energy costs between fossil fuel and renewable, but there's also economic benefits to investing in renewable technology. So is it really true that we are definitely asking them to be poorer versus just asking them to invest in different technologies, which could make them just as rich?
I think the unfortunate truth is that at current prices, asking them to reduce carbon emissions is asking them to be poor. There will also be some benefits for them in the sense that climate change will be less fierce and less intense. But I think there's no getting around the basic math that it's more expensive to get a kilowatt hour of electricity from renewables than it is from fossil fuels. It's a unfortunate and painful problem.
Professor Moniz?
Comment and a question. Actually, the comment on Michael's statement, I mean, clearly the numbers you showed, I agree, are obviously the costs. But obviously, there are many contexts in developing countries where, for example, they're also paying $10 for a gallon of diesel. So I think it's a little bit more nuanced, I would say, than that.
So let me, before you get your question, let me just cut you off a little bit.
That's my question.
Yeah. And say, those are average prices for a kilowatt hour produced in the United States. There will obviously be contexts where they could be turned around.
The question with Sandy, this is really a possible infrastructure and adaptation question. With Sandy, we saw obviously a relatively quite wealthy community, electricity out for up to 3 weeks. Where does the Commonwealth stand in terms of resilience against major storms in the energy infrastructure? And you made a comment, Stephen, that we're not going to accelerate infrastructure renewal, but will incorporate climate change when we do infrastructure renewal. Well, why don't we, in fact, invest in new infrastructure that may be of economic benefit and build in robustness and resilience when we do that?
Do you want to hit energy?
I can answer the energy.
Yeah.
I'll answer the energy side of the question, and then, well, I think that you've identified a major problem and concern for us. This whole notion of storm damage, there's sort of two sides of it. Sort of on the operational side, I think Massachusetts actually does have its act together as much as any state can at this point in time. Our legislature mandated emergency response planning to a very high level. So on that side, on a particular issue, I think we probably will do as well as any other location in the country, if not better. In terms of your other question, we're looking into issues related to smart grid. We're very concerned about cost. Cost of infrastructure renewal and new infrastructure is very, very expensive at a time when people are very sensitive about energy prices. So at this point in time, I think we're looking to technology, we're looking to smart grid. But again, I think our vulnerability remains very large, and these are the big resource choice questions that over a period of time, we're going to make. And I think they're going to be very difficult and very expensive.
Yeah, in the world I live in, which is a place where we've spent $6 billion in the last 25 years upgrading a significant portion of the water and wastewater infrastructure, each dollar we spend has to be closely looked at. And we're spending money to make sure that the systems are resilient to a wide variety of things. We're making sure that, well, we have pipes in the street that were old when Lincoln was campaigning in Boston. I'm looking at some 1860s pipes in Beacon Street underneath the railroad tracks right now that we're having to do some work on. So we look at all of those investment needs. So what we're saying is that we want to be efficient in how we adapt to climate. Not just adapt, but be efficient in how we adapt. So if I have a project that I'm working on, I want to make sure that climate adaptation is fully integrated into that. If I've got another facility where it does not have a terrific risk today of being damaged in a storm, but it might when sea level rise occurs over a series of decades, I can queue that up and say, I'll be there because I'm going to be back. It's not as if we're saying we'll never be there. If it's got moving parts, we're going to be there within 20 years. Now, my investment cycle on a building project is about 15 years. If I want to work on something today, I started thinking about it more than a decade ago. It takes that long to get through all the design and engineering and construction. So we're not really talking about being slow. We're talking about being smart, making sure that we're doing things where we are already touching it. Plus, the other issue is if you're going to tear apart a building, you want to make sure you're doing everything. So I don't want to go ahead and do climate change adaptation if I'm not also doing everything else that needs to be done. So it's scheduling more than anything else.
Can I just add something? Can I add something here, Bobby? Just in terms of the politics or the reality, how do we get this done? I think we had sort of in a really interesting place right now, and I'm just saying because we're in Massachusetts, the governor just announced, right, a budget. And he talked about two things. He talked about education, and he talked about transportation, infrastructure. And the big thing about that statement is that I'm proposing this. I know this is not going to be popular because I'm saying we're going to have to raise revenues. We have to pay for it. Now, we're not talking climate, we're talking now transportation, something that affects us all, but we need revenue, we need taxes to do this, and we can keep talking about how are we going to do this, it's important to do, but are we willing, are we going to bite the bullet and be courageous and responsible enough to say we have to pay for it? And how do we pay for it? So I think we can keep dancing around this all we want. We can talk about climate change, but we've got to be able to say we've got a responsibility to pay for it.
There are many, many questions. Professor Moniz.
You have to pay afterwards if you don't prepare.
Well, absolutely. No, absolutely.
We understand that, but it's a difficult message for us to get across. First over here, and could you identify yourself before you speak? I think it would be helpful.
I'm George Mocray, an independent scholar from Central Square. On Friday, Alan Savory, the inventor of holistic management, is going to be talking at Tufts. And that's a kind of, you can talk about an ecosystem version of geoengineering or geotherapy. So if people are interested in this, they should go to Tufts at 2 o'clock and hear Alan Savory. I don't think that there's much difference between the developing world and the developed world. If you look at what happened at Hurricane Sandy, people in New York, right, one of the premier cities in the world, were reduced to the level of basically the people in Haiti. All right, so climate change brings us all down to the same level. It's also very complex. we talk about carbon, but there's also methane, and we've talked a little bit about that. There's also black carbon, soot, and tropospheric ozone. The UN EP released a report about a year and a half ago on short-lived climate forcers, which is black carbon, tropospheric ozone, and methane as a precursor to tropospheric ozone, and suggested that in the developing world, dealing with these things actually has real economic and health benefits that pay off, not only in terms of local and world climate within a month, but also economically. And then we also read about the BU test walking around Boston looking for methane leaks. So it's the same problem here. All right, so things that we can do both in the developing world and in the developed world that deal with climate change. Last point is that the International Energy Agency, in their World Book of Energy, their energy resource this year that they looked at in depth is efficiency, which they said can buy us another 8 years. Again, that's something that tends to pay off immediately. It's not a capital cost, but actually a benefit in the short term. So there's a lot of things that we can deal with, and I would like you to address that: black carbon, tropospheric ozone, methane, and the idea of efficiency.
Why don't we first turn to you, Professor Emanuel?
Well, I think you make a point that it's good, and it's been made by the IPCC. There's some low-hanging fruit here. It's not all about greenhouse gases. There are also aerosols and other problems that have immediate health consequences that have nothing directly to do with climate. And there's a terrific benefit to reducing them and not much cost. And black carbon is something that we're still arguing about a lot, but there's no question it's an effect. And one of its sources is basically personal stoves that are used, for example, throughout India, which have big health risks as well. And anything that can be done to help shift away from that produces a very immediate effect. So it's a complex issue. There are a lot of things that are driving the climate, and in 15 minutes you tend to focus on the things that are really the long-term monsters, but there are some short-term things that need to be fixed.
Is there anybody else on the panel who'd like to address the question?
I'd just add, in terms of long-term monsters, I think there's some hope. I don't know if it'll happen, but that China will begin to conclude that the excessive use of coal is causing immediate health problems in ways that could be beneficial to their current health and beneficial to climate change by moving away from coal.
On the issue of methane leaks, we're very, very aware and sensitive to that issue as well. And the BU professor did come in to speak to us. The Conservation Law Foundation also has written a paper on that topic as well. And in the total scale of things, one would think that this is a very fixable, doable problem in the developed world, in a major city. What we have to think about, and again, costs, short-term, long-term, I think it's an issue that we are paying much more attention to, and I actually think that's a solvable problem. We just have to be willing to pay for it. And the other issue to raise is consistency over time. One of the issues that we have in energy policy is a piecemeal approach. One administration comes in, another administration, it leaves, another administration comes in. And while we all may be committed to such things as methane reduction in our pipes, what we really have to do now is put in place long-term, consistent solutions to these problems. So I think we're very focused in doing that in this administration, and that's a good example of where we can deal with it on a rate making and a science and also an industry solution as well. So it's a stakeholder process, and I'm sure that there will be a solution to that problem over time. Yes, would you like to tell us who you are? And
I'd like to take issue with Professor Greenstone's statement that we really have to concentrate on adaptation since it looks pretty grim for mitigation. And I think he is using costs, current costs, rather than projected costs to come to that conclusion, and current political log jams rather than what is happening, for example, in China. If you extrapolate the cost increases of carbon energy, including the externalities of the cost of climate damage, and you extrapolate the decreasing costs of renewables, particularly solar, wind, tidal, geothermal, hydro, and so on, which are, with increasing economies of scale, becoming more economical. These curves cross, and in some areas have already crossed. And increasingly in rural areas around the world and in the major polluters, which are currently China and the US, will increasingly cross. So obviously, everyone understands that we have to buy insurance against both flooding and increasing temperatures, but I don't think we should give up on mitigation, and there's a lot of good prospects for that. And there are studies that show that the green economy can create jobs and accelerate economic development rather than merely be at the sacrifice of economic development.
Thank you for your comments. I seem to have touched a nerve. Let me just say, if I gave the impression that I think mitigation is a bad idea, let me correct that. I think the world would be better off with a good mitigation program. And in fact, mitigation would necessarily involve raising the cost of fossil fuels, which in turn would make renewables look like a better deal. I think what I was trying to express a little bit more was I don't really see the politics of that taking shape, partially based on the economics. People are used to buying their energy based solely on the private costs of producing it around the world. China seems thus far perfectly happy to incur all kinds of health costs in exchange for low cost per kilowatt hour of electricity. So I think we should continue to work for mitigation, and I think the thesis of my talk was much more that while we continue to work for that, I think we should not be blind to what looks to me like trends that suggest climate change is here and it's going to get worse, and we should be prepared for it. It would be unwise to ignore that.
Yes.
Hello. I'm a current MIT freshman, and I'm, I guess, at this stage compiling information about different issues such as climate change. And it was recently brought to my attention by a classmate that the effect of water vapor as a greenhouse gas is rather significant in relation to CO2. So I was just I was curious about your thoughts and your exposure to the idea of some of the effects we've seen of global warming, or I'm sorry, climate change. Sorry. As a result of non-direct byproducts of industrialization.
Okay, I'll have a shot at that. So water vapor is far and away the most important greenhouse gas in our atmosphere. It's mostly because of its abundance, molecule for molecule. Excuse me, methane is more effective, but there's a lot of water vapor. The reason that we don't talk about water vapor is actually quite straightforward. It's the average residence time of a molecule of water in the atmosphere is 2 weeks. In other words, it cycles through the system very quickly, and very quickly comes into equilibrium with the climate state, mostly with the temperature of the climate. So if I blew up some kind of magic bomb and doubled the amount of water vapor tomorrow, in 2 weeks it'd all be gone, okay? So climate or water vapor has to be considered on the timescales we're talking about, a feedback effect. It's a powerful feedback. If you warm the climate by some means, solar, greenhouse gases, what have you, water vapor concentration goes up according to something called the Clausius-Clapeyron equation. It goes up more or less exponentially, and that feeds back onto the climate state and produces more water. So there's not much you can do about water as a feedback mechanism. It's there and it has to be dealt with as part of the response of the system. I hope I answered your question.
CO2 centuries might be worth.
Sorry?
CO2 for centuries cumulative.
Yes, and I should have said, that's a good point. Ernie reminds me to say that in contrast, CO2, the residence time of a CO2 molecule is 1,000 years or so. That's why we treat it quite differently. And it's much longer than methane, by the way. So in the long run, it's CO2 we have to focus on.
Yes, you. Here comes your, and while you're getting your microphone, I just want to thank Amanda Graham very much for being the glue that has put all of this together, because we would not be here without her. So thank you.
This is for Greg Watson. I'm deeply concerned about food and water security in general. And I think about agribusiness, and I think about the federal government as a collaborator with agribusiness and the subsidies that go toward that. I'm wondering what you think about the costs of food, because I also think we deal with artificial costs all the time, and the costs of food today are artificially lowered because of all the subsidies. So when we're working independently, like in Massachusetts, how do we compete with large agribusiness that doesn't have that kind of money coming in to support them, and where people are feeling, I hear it all the time, I can't afford that, I can't afford organic or local agriculture. We need to do something about that. So I'm curious how you think we'll have a level playing field.
Yeah, just a couple of responses to that. We clearly going to see, for instance, there are going to be changes in the Farm Bill, and some of those big changes are going to be a sort of pulling back from the subsidies, particularly large commodity subsidies, soybeans and corn, as I mentioned before. Massachusetts farmers, New England farmers don't qualify for any of those because we all deal with what's called specialty crops. That's the stuff that's not the commodity grains and all, it's the fruits, vegetables and all. The biggest subsidy, and you did connect the two, is really the water subsidy. Without the water subsidies, and I don't know if you recall, but Jimmy Carter tried to address that when he was president, and that probably had a lot to do why he didn't get elected the second time. He just realized that that is really what's sort of creating an uneven playing field. I don't think we want to not have affordable food, and I think, but here's the issue. What really is affordable? 1978-79, Farmers Market, Dorchester, Boston Globe reporter goes up to a single mother and says, you're buying this produce from a farmer, but it costs more than the produce at the supermarket. Well, why are you doing that? And the mother kind of looked at him sort of like, again, kind of like incredulously and said, because they eat it. And basically, and the freshness, and she wasn't being facetious. She said, doesn't it make sense for me to pay a bit more? And look at that, they were eating the stuff fresh, raw, the peas, as opposed to buying it a little cheaper from the supermarket and then it's scraping 75% off of it into the trash bin. So we are finding that the quality, when we can make the connection, that's why the local movement, the local, buy local movement is really catching on. People are making that connection in terms of the quality of the food, and that it probably makes more economic sense to do so. And finally, because this is an important piece, the health connection. Last Friday, I was at a meeting at the nonprofit center in Boston, and it was to promote this program called Veggie Prescriptions. You had health centers, physicians, farmers market operators, and ag commissioners there to talk about the fact that to deal with the problem of nutrition, obesity, perhaps the best thing we can do is to really get children hooked on fresh food. And the way they're doing that is, it is a subsidy. Doctors are able to prescribe fresh vegetables from farmers markets and community-supported agriculture, but they can give them a voucher for up to $20 to go and do it. So we're concentrating on women, infants, and children, WIC, SNAP recipients to do that, and there's a whole infrastructure that's really designed around it. But it is education, it's public awareness, and probably not to spend too much time trying to tear something down, but to build something that we have that's really good and to build it up.
I say thank goodness for Massachusetts, because this is probably, in many respects, the result of progressive policies on a whole range of issues where we're making these amazing connections. So the question for me always is continuity from administration to administration, so that we don't lose the progress that we've made.
Absolutely.
With clarifying question
Sure.
for Mr. Greenstone, are subsidies integrated in your costs? Sorry.
Are subsidies integrated in the costs when you started listing from coal?
No, so that's an excellent question. So I list the costs we actually pay. I have a second graph, which I didn't show today, which shows the true costs, and it changes the playing field dramatically, and it makes the fossil fuels look much less attractive.
Exactly.
The costs are twofold. There are the health costs from breathing in particles, and then also the long-run damages from climate. But we don't have an energy system right now where we pay for those social costs up front. We just pay for them later.
Right. Yeah. That's right.
Mayor?
Just on just a few weeks ago, we had a major blackout in Cambridge. We had no electricity for 2.5 hours. Now, that was pretty shocking all by itself. But the most shocking thing was that the first responders in Cambridge did not know where the blackout was.
Mm-hmm.
And it was I was organizing an event in Harvard Square. Harvard closed down one place, another place wasn't closed down. Our bunker was next to one of the buildings where there was power, and they didn't know the power was there. So I think this electricity power grid issue, it's not going to wait for not for very long. If Sandy had come our way and that had happened, and we had such a poor understanding of where the electricity really was running and not running, it would have been, well, probably as bad as New York, I guess. But I had no idea as an elected official just how little we really know about electricity until that happened. And I guess I urge us all to take this very, very seriously, because it's going to keep the wheels of everything from running if electricity goes out and we don't know how to fix it.
Right. Well, we have a smart grid initiative that the Department of Public Utilities now is totally focused on. It's one of its highest priorities. Issues like that, it is sort of shocking that the utility doesn't know which customers are out, that they depend upon the customer to make the call to let them know that there's a problem. I mean, especially the old hackneyed joke is that if Alexander Graham Bell came back, he wouldn't recognize the telephone system, but if Thomas Alva Edison came back, he would totally recognize the electric grid. So, we have deferred a lot, and now we will be focusing on it.
That's good. I like that.
Yes, over here.
Hi, I work for the city. I'm an environmental planner. I work on the city's climate initiatives, and the Commonwealth's been a great leader in terms of on the mitigation side of things with RGGI and the Leading by Example program and many other things. And it's also put out a great adaptation report, but it doesn't seem the Commonwealth is emphasizing implementation of a lot of the things that are in that report. So I'm wondering if you can tell us what's going to be happening in terms of the next steps and ramping up what we do on adaptation at the state level.
Well, I'd love to do that. I also have my fellow partner in crime, and it's not fair for me to totally answer that question. I will, but I think it would be very nice if Undersecretary Griffiths also had a moment to talk about some of the things we're doing. Our team is here. It's a difficult question, and we are moving ahead. And Brian Sweat is on our implementation committee.
He's a boss. Right. I think one of the part of the answer to that question is much as Steve Smargiassi said from the MWRA. You look at every single one of our agencies, whether they're regulatory agencies, planning agencies, infrastructure agencies, and how do you integrate adaptation planning, thinking about that 20-year cycle, and what are you engineering for when you go in and reinvest. And we work very hard at making every one of our agencies and folks on infrastructure start that planning process early and figure out what they're doing, so that every time they're going in and looking at a regulation, a capital budget, an operating budget, they're going in and they're asking that question: what are we doing to integrate adaptation for the climate change that we know, and the engineering standards, the building standards, the investment cycles. And so we spend a lot of time working at that at a very base bureaucratic level across all of our agencies as the starting place to do it. I think the other thing that we begin to look at, one of the things that I've observed in just in the last year or two, the conversation about adaptation seems to have changed significantly from one where we looked about long-term environmental impacts, where were different species going to be living, where were diseases going to happen. And in the last year or two, we begin to, the question that gets asked is emergency preparedness. And it's a very different question that is being asked of us. And from a political perspective, you have to think about what can you actually make happen in that environment. So we're beginning to change much of our thinking about where are the opportunities for us to invest in emergency response, emergency preparedness, so that we can be prepared for it. And that's where the opportunities are going to come up. So you're beginning to see our focus change towards answering those kinds of questions. And it's continually, from where I sit, which opportunities are presented to you for you to take advantage of. And that's part of what's happening now, is that game is changing in front of us as we speak about it. Emergency preparedness is where it is now. So we're looking at how do we get at those issues in terms of the opportunities that are presented to us.
But what about resilience planning? I mean, I think emergency preparedness isn't going to do the job when sea level goes up just 2 feet. There's going to have to be a lot of capital planning. The mayor's mentioned the Charles River Dam, which we're very concerned with, and we know that probably only in the next 30 to 40 years we're really going to have to worry about areas like MIT and Kimball Square flooding, and we can't do that here.
Yeah, so I do think we look at that at a lot of our, if you look at our, the way we budget for various things, you look at what the Department of Transportation is doing on large scale planning for resilience, you're looking at the Central Artery and Turnpike, things like that. They're spending their time looking at those questions. We do it with the agencies that we work with the MWRA, with DCR that does all the flood control issues in the Commonwealth. We begin to ask those questions. You've got to start by asking the question and really doing the analysis and the vulnerability assessment to begin with, and we're doing everything we can to find the resources to fund that kind of activity in every way that we can.
We've lost time. I think we have lost time, and we recognize that, but we're trying to move forward now. I mean, I think that's sort of where we are on a lot of these issues. And is there any other comments? Yes, sir.
Well, I'm just here as a visitor visiting scientist from Sandyland or New York. And in both places, something almost as reliable as taxes is the, bi-daily tidal flow. Is there much potential for developing tidal energy in coastal states like Massachusetts and New York?
It's an alternative strategy that I believe that, that we have looked at. I know New York City had a tidal project in the East River. Again, these new, and I can turn it over to some of our scientists here, and I don't know if you have something to add, that you would like to say. But again, I think it's a strategy. It's still in the future because the reality of the situation is that, it needs to be put into pilot projects and move forward from there. But from a science perspective, I didn't know if there's more to be added or an economic.
I would only make the point that I think all potential resources should be put on the same playing field, and we should figure out what are the least expensive ones so we can get the biggest bang for the buck in reducing carbon emissions. But from my dear colleague Ernie Moniz's shaking of his head, I suspect tidal energy might not come out that well. Is that fair, Ernie?
Well, it's certainly in the research stage.
It's in research.
To become economic.
Yeah.
Professor Moniz?
Just since we're getting to the end,
right?
To ask an unfair question. Kerry, you're the hurricane guru. How much time do we have to address these infrastructure questions? Will this leisurely approach be sufficient?
Well, to answer your question is the time scale is actually negative on that issue. It's part of the problem is not, I mean, there's climate, but on top of that, we have policies in place that encourage people to live and build in risky places that are long-standing, that unless those are reversed, we can't even start to address the climate element of that.
In fact, if I may follow up with our state colleagues, to what extent are you in the Commonwealth really working with insurance companies in terms of how some of these questions are addressed? Because they are politically sensitive.
I don't know if, at this point, we know it's an issue. I have no concrete experience myself, but perhaps Phil's agency.
I can comment on one thing. When we issued the Climate Change Adaptation report last fall, the insurance industry was very heavily involved in us in coming up with the range of issues that needed to be addressed and understanding the scope and scale of the problems. Much as the question came from over here, that was a wonderful report that told us the breadth of things that we needed to get to. And we're still trying to figure out how do you go to the next stage of engaging them in constructive policy solutions and programs that can actually change what's going on.
The Commission is allowing highly differential rates?
Yeah, we need to begin to evaluate those questions. And I think they're critical to anything we do in the implementation of anything we want. They're going to be a critical part of that process.
Can I ask a follow-up question? I had heard reports that in some parts of the world now it's impossible to get insurance, hurricane insurance, so that basically there's no price anymore?
That's right. I mean, it's in places where insurance is heavily regulated. If the regulators create a very large gap between a premium and what the risk demands, the only intelligent strategy for the insurance company is to pull out. And that's happened massively, actually, here in the United States. And it's a place where I argue that free market people are natural bedfellows with coastal ecologists. Right? Maybe the only place, but their interests are both served by loosening up the regulations that make it too cheap for people to build and live in risky places.
I think we have had a great afternoon. I don't think we've solved any questions, but I think we've asked additional work. And just to let you know that next week we are doing something else. We have student presentations really looking to the future because even though this is a problem today, it's really the next generation that will give us the answers to what we have struggled with. So I can't thank the panel enough. Thank you, Amanda. Thank you, Professor Moniz.